Welcome back. In the previous steps, we talked about constructors and how they are helpful in initializing the state of an object. One of the things that happens typically in programs is the state of the object keeps changing. So let's say over here, I would want to increase the speed of Honda. I can say Honda.speed is equal to Honda.speed plus 150. So I'm increasing the speed by 150. This could also be done by just saying Honda.speed plus is equal to 150. Or I can say Ducati.speed plus is equal to 25. So what we are doing in here is we are modifying the state of the object. The thing is we are modifying the state of the object outside the class. So outside the class, we are writing code to modify the state of the object. In this step, we will talk about encapsulation and how we can encapsulate this kind of behavior directly inside the class. Now, let's get started with encapsulation. Encapsulation is one of the most important object-oriented principles. That basically says all data and data changes should happen through methods or through behavior of a class. So over here, how are we increasing the speed? What we are doing to increase the speed is we are directly changing the value of the attribute. That is not really considered to be a good practice when it comes to object-oriented programming. Ideally, the increase in speed should happen through a method which is defined inside the motorbike class. Let's now look at how to define a method inside the motorbike class. Now, how do you think we can define a method? Very simple, right? So I'll just press enter in here and start defining a method inside the motorbike class. The most important thing is this is at the same indentation level as the constructor. So def, I would need to name the method. I would want to increase speed. As soon as I press open parenthesis, it would give me self as a parameter and it completes the rest of the syntax. That's one of the things IDE does. But the important thing is for all instance methods, we need to pass self as one of the parameters. If you don't pass self as a parameter, you would get an exception. We will look at it a little later. For now, let's focus on increasing the speed. When we want to increase speed, how do we increase speed? We would want to increase speed by some value, right? So I'll call this how much. So how much do I want to increase this speed by? And over here I can say self dot speed plus is equal to how much. So what happens now is I can increase the speed using the behavior. So I can say Honda dot increase speed and pass in how much I would want to increase it by 150, and Ducati dot increase speed, how much do I want to increase it by? If you print, I'll remove the statements from here and I'll print them down here. Let's run this. You'd see that the speed of Honda becomes 200 and the speed of Ducati is 275. 250 plus 25 and 50 plus 150. What we are doing now is we are increasing the speed through behavior on an object. So our objects right now have both state and the behavior. Let's print the values before the increase of the speed as well. And let's run this. And you'd see that over here, the Honda.speed is 50. Ducati.speed is 250. And we are increasing speed. We are changing the state. How are we changing the state of Honda? By calling the behavior, by calling a method on the Honda object. So our Honda object, the state of it was speed of 50 before this. We are calling a method to increase the speed and we are changing the state of Honda object to increase the speed to 200. So our object has both state and behavior, and the change in the state is happening through the behavior of the object. What we are doing here is we are encapsulating the logic of how to increase the speed inside the class, and this logic can be reused on all instances of the motorbike class. Now, what if I want to decrease the speed? So we have increased the speed, but what if I want to decrease the speed? I'm copy pasting the entire thing and I'm changing the method name to decrease speed. Decrease speed. I would want to decrease the speed by 50 and decrease the speed by 25 again. I can easily decrease the speed by creating another method, right? So all that I need to do is put it in here. So I'll do decrease speed, self, how much? Here, speed is decreased. Isn't that cool? Now, if I run this, you'd see that the speed of Honda is decreased by 50 and Ducati is also reduced by 25. So 275 becomes 250 and 200 becomes 150. So in this short video, we created behavior on the class. We created a couple of methods, increase speed and decrease speed, to enable us to increase the speeds and decrease the speeds on instances of motorbikes. We executed the methods on both the Honda instance and the Ducati instance. I'll leave you with an exercise. Enhance the book class that we created to have a new property called copies. How many copies of the book are available? And have methods to increase the copies and decrease the copies as well. Another thing is to have copies as a constructor argument. Make sure that you are setting an initial value when you are creating an instance of the object, and have methods to increase and decrease the number of copies. Do that as an exercise and I'll see you in the next step with the solution. Until then, bye bye.